Charles's laws applications to problem solving. In this short video, we'll just tackle how to apply our Charles's law mathematical equation of the inverse relationship of pressure and volume and temperature. We know that Charles's law, just to recall, it was V1 T2 is equal to V2 T1. That is the final mathematical expression of your direct relationship of volume and temperature. So let's apply that particular equation to this problem here. You have a 600 ml sample of nitrogen gas that's heated from 27 degrees Celsius to 77 degrees Celsius at constant pressure. And of course, that's constant amount. What is the final volume? So again, in every gas law equation, you have to segregate the final and the initial so that you can substitute it correctly in the variable. So 600 ml, that is considered to be your V1, 600 ml of sample, and you heat it from 27 degrees to 77 degrees. So 27 is your initial temperature. And you know that in all temperature units in all gas laws, it has to be converted to Kelvin before you substitute. So it's better that you convert it in the given first so that the whatever is the final temperature, that's what you will substitute. So that's plus 273.15 Kelvin. So this will now become, the sum is 300.15 Kelvin. So that's the final Kelvin temperature that we will be using. And then 77 degrees, that is your T2. So 77 degrees Celsius, we have to add 273.15 so that we can get the Kelvin, which is 350.15 Kelvin. Now we're ready to solve for the final volume V2. So to solve for V2, we need to get rid of T1. That means the final equation that we will use for this is V2 is equal to V1 T2 over T1, because we need to divide both sides by your T1 so that you can remove that, correct? So now we're ready to substitute. Our units are okay. So that is 600 ml times T2, which is 350.15 Kelvin over 300 Kelvin, 300.15 Kelvin. So putting that in the calculator, inputting everything, and please, I hope you're doing that right now, you will get 699.95 ml. So this becomes our final answer. This is 699.95 ml of nitrogen gas. You have to put the substance. So that's a final volume of your nitrogen gas. So again, one thing to remember and to watch out for in Charles's law, because it has temperature, you have to make its unit in Kelvin before you substitute it in the equation. So you have to be familiar on converting it. In this case, it's just Celsius to Kelvin. That's why we just added 273.15. But it's possible that you might be given Fahrenheit. So you convert your Fahrenheit to Celsius first, then to Kelvin. And it's also possible that in the final, if you're looking for temperature in Charles's law problems, that final temperature has to be not in Kelvin. It can be Celsius or Fahrenheit. Whichever is the case, you have to start with Kelvin first, and the default unit of temperature is Kelvin. And then in that final answer, that's when you start converting it to the unit being asked in the problem. So that's it for the application of Charles's law in problem solving. Solve more problems in the classroom, and always remember that this is not hard. It's just that it requires for you to really practice and remember one by one each of the gas laws and be consistent with the effort you're putting into your work. God bless you. Thank you so much. And for the next series, watch for Gay-Lussac's law. Bye for now.